Great. Welcome everybody to the Vermont Ag Water Quality Partnerships Lunch and Learn Conservation Webinar Series. We're excited to be discussing unmanned aerial vehicles today in conservation planning with Izzy Bazluke and Newman. And I just wanted to share a couple slides about our partnership as a refresher. So the vision of the Vermont Ag Water Quality Partnership is that Vermont will be populated by farms that are vibrant, robust, and sustainable, and who steward their land to improve water quality as well as wildlife habitat for the benefit of farms, connected ecosystems, the public, and the general good of Vermont. And we have a purpose and mission that's outlined in our 5-year strategic plan. Our purpose and mission is to improve ag water quality in Vermont by coordinating all of the partner efforts that are going on to provide education, technical, and financial assistance to the farming community. And in doing so, we have 3 main overarching goals. The first is to improve water quality and wildlife habitat on all engaged farmland owner operators' properties, that we want to deliver technical and financial assistance in a way that's efficient and effective in meeting our collective watershed goals and water quality goals. And thirdly, we want to provide the best experience possible for landowners participating in our programs. So thank you. With that, I'm going to hand it over. Thank you.
All right, let me just share my screen real quick. All right. All righty, can everyone see it?
Yep, I can see it, Lauren.
Perfect.
So our presentation today is VACD's Small Unmanned Aerial Systems Program, commonly called SUAS. And my name is Izzy Bazluke, and my fellow presenter today is Newman. And our titles are GIS and Natural Resources Planners, working in the Colchester NRCS Vermont State Office and the St. Albans NRCS Vermont Field Office, respectively. And we are co-operators and FAA licensed pilots of the SUAS program for the Vermont Association of Conservation Districts. And VACD is a nonprofit organization whose mission statement is to conduct educational, scientific, charitable work concerning conservation, maintenance, improvement, and development, and use of land, soil, water, trees, vegetation, fish and wildlife, and other natural resources in Vermont. And so our drone program helps to accomplish this mission through the focus on innovating conservation planning and design with new technology. And so a very brief background on the program itself. In the summer of 2019, we took a workshop with the UVM Spatial Analysis Lab, which really helped to start our program. And in the workshop, we learned about software requirements, different drone models, and different sensors available. And we became FAA certified pilots in the summer of 2020. And then that fall, we started our SUAS program. And we began officially flying pilot projects in the spring of 2021. And so all the data and projects that we discussed today will come from the 2021 field season.
So the current NRCS drone policy is based on early rules and regulations from the USDA, the Federal Aviation Administration, the General Services Administration, and the US Congress. Currently, they are not permitted to own or operate drones, but they can work with outside entities such as soil and water conservation districts or universities to operate drones on their behalf. Because of the VACD NRCS partnership, VACD can operate unmanned aerial vehicles, also referred to as UAVs or drones, for NRCS projects, can use NRCS equipment such as GPS units, and have been provided with SiteScan, our flight processing software. And currently we have only flown for NRCS projects, but hope to expand soon. We have a Phantom 4 Pro version 2.0 that we have named Rachel Flyson after the biologist Rachel Carson. She is a quadcopter UAV, which means she flies using 4 rotors. We can perform pre-configured automated flights, and from those are able to create natural color ortho imagery, digital elevation and surface models, point clouds, and contour lines. Additionally, from a freehand flight, we can collect MP4 videos and oblique photos. Also, we bring the Topcon GR5, a surveyed grade GPS, to collect ground control points when flying an elevation survey. Izzy, I can't hear you if you're speaking.
Sorry. Lord and I do more than just simply fly our drone. We are also in charge of outreach, project planning, mission operations, and post-flight processing. For project outreach, we maintain a story map for information on our program, the types of projects we fly, and other information. And we have a link at the end of this presentation to our story map. We also have a Survey 123 project proposal form for project requesters to give a description of the area of interest, the type of projects, and the products desired from the outcome. And the survey will also prompt the requester to draw their area of interest on a web map, and then that is synced with our flight planning map. And so we plan all of our projects in advance of the flight date, including where we're going to place the ground control markers, where the pilot should be placed, and we can measure our visual line of sight using the drone and to make sure that we can see it throughout the project area. We also require landowners to sign a release form for permission to fly over their land, and we make sure to train visual observers or other participants in the flight. And they assist in maintaining visual line of sight with the UAV at all times. And of course, we actually perform the flight operations themselves. Following the flight, we perform a post-flight checklist, which assists in this inspection of the UAV, the operating environment, and it'll help us record any errors or abnormalities that we find. We also record fleet metrics like battery consumption, duration of the flights themselves, and a brief project description. And after all that, we process the data with SiteScan, which is a cloud-based software, and then we can provide any derivative products using ArcGIS Pro. Some types of projects that we have worked on are engineering surveys. We've inventoried resources. We do wetland surveys and monitoring. We've used the UAV for practice certification for 315 herbaceous weed treatment and 657 wetland restoration, and also some various promotional projects. And the map on the right here shows the geographic distribution of flights in 2021. We flew a total of 51 times from April until November. And we will touch on some more specific examples and details in just a little bit.
Overall, we have done 16 projects covering 1,083 acres in almost 18 hours. Our longest single day project was 139 acres. So with Rachel, we are flying about 1 acre per minute and are flying an average of 20.8 acres a flight. For pre-flight planning, we spend around 42 minutes on site, which includes the flight time. We are spending about 140 minutes, and doing the post-processing and preparing all deliverables is about 40 minutes. We have flown over a variety of land uses, with farmsteads being the most with 6 projects. Crop fields have 4 projects. Associated ag land, which includes our wetlands, has 4 projects, and forested and pastured land has 1 project each.
We've mentioned ground control points a couple times now, and I just want to define it. It's a point on the surface of the Earth of known location using georeference data. So basically, it will assist in ground truthing the data we collect with the drone. So we use the Topcon GR5 survey grade GPS, which collects X, Y, and Z coordinates of our ground control points. And that's needed because absolute accuracy of the data from the drone may shift between 2 and 8 feet. And although this accuracy is great, our engineers really require a higher level of detail for their designs. So it has been recommended to use a minimum of 5 ground control points for any field size, and for any flight that's over 20 acres, it's recommended to add an additional ground control point for every 15 acres. And they should be evenly distributed throughout the area of interest, so it will involve us walking that area. Our ground control markers are the checkerboard pattern that you can see on the right in the photo, and our processing software SiteScan can detect them during the image processing. And as mentioned earlier, we use an offline enabled web map for planning the placements of these ground control markers prior to our field visit, which you can see on the slide. And we then can use a mobile device in the field to navigate to the appropriate area so we can place the markers. And ground control points are required for our engineering surveys, and we're going to talk about that next.
So here's a comparison of LiDAR that was flown in 2017, a GPS survey done by our civil engineer who walked a 75-foot by 75-foot grid, and the UAV survey. The surface you are seeing is a TIN, which is a triangular irregular network, and was created by the engineer in AutoCAD. With the TIN, the larger number of triangles and the smaller square footage per triangle results in increased quality and accuracy of the product. The UAV provided a triangulation that was 2 times more detailed than the LiDAR and over 31 times more detailed than the GPS. The UAV survey was done 4 times faster than the GPS, and the flight included the buildings and other structures. For this test, the buildings and structures were not captured with the GPS. We can provide contours as low as 0.1 feet. In this scenario, 1-foot contours were provided at the request of the engineer. You can see in the table, the mean elevation is consistent. The mean slope differs because there is a pond that was easily captured by the UAV and LiDAR, but our engineer could not access it. Vermont LiDAR is 4 to 9 years old, depending on where in the state you are looking. So areas severely affected from major storms will not be shown accurately in the LiDAR now, which makes the UAV a great asset. These elevation surveys do require minimal vegetation, so we have to fly them in early spring or when the vegetation has been cut. The flights do save engineers time in AutoCAD compared to their traditional methods of conducting an elevation survey. Currently, engineers are using the elevation data from flights to design clean and wastewater ponds and for irrigation. And here's a quote from that engineer who helped us with all of that data. The UAV survey made it possible to survey large sites, which can take 2 to 3 days in just one field visit. Not only was the survey time efficient, but it also provided a remarkable level of topographical detail that significantly reduced the time spent on adjusting the triangulation in CAD. And I am going to hop over to SiteScan, our flight planning software, sorry. And here is one that we did with the engineer. So right now I have 1-foot contours on, and the purple lines are 5 foot. We can filter out the buildings and trees. For this demonstration, we've decided to keep them in. So you have up-to-date contours here. I'll click those off. This is the surface model, which means each pixel is an elevation value. Here is the hillshade, and a hillshade shows a clear picture of the topography by mimicking the sun's effects. So the sun here is coming from the northwest. And here is the up-to-date ortho imagery. What's really great about the UAV is that it's first off way more detailed than any base map. And also it captures, as I said, up-to-date imagery. So if there's been work that's been done on the farmstead, it is easily shown here and can be a huge time saver for engineers. I'm gonna show you the point cloud from that site. So a point cloud shows all of the elevation points that were collected during the flight. And in this, you can click around, get all the X, Y, and Z data wherever you want. You can do a lot of measurements in this, really good for a lot of work. But what I want to show you here, for anyone who has used a traditional GPS, you know that it needs to connect to satellites. And the closer you are to structures and trees, the less satellites you're going to connect to because of all that interference. The drone does not have to worry about that. As you can see, it really got this overhang here and all of the area underneath it. Something that would be very difficult to do with traditional GPSs. And I'm just gonna hop on over to this other side of the barn where I have a profile already set up. If I can click around to it, perfect. We can do elevation profiles. So again, get all that X, Y, Z data of hard to reach areas with a traditional GPS. And finally, the 3D mesh, and this just provides a really unique view of the farm site. It looks similar to the point cloud, but it's neater and it does not provide any measurements. It's solely for the looks, but can be super helpful when planning. Izzy, I think you're muted again.
Oh, I was just waiting for the slide to catch up. I'm ready. So another type of project we've worked on this past summer is flights for wetland practice certification. So in addition to being a pilot and a cartographer, I also work on the NRCS wetland team and work closely with Jim Eikenberry, the NRCS wetland specialist. He provided me with this quote: "The VACD UAV program has been transformational in its assistance to our wetland restoration and easement monitoring program. Using the UAV has increased our efficiency, effectiveness, accuracy, and safety in our natural resources, inventory, conservation practice certification, and easement monitoring work." And so speaking especially on safety, the UAV has allowed us access to areas that may otherwise be inaccessible during flooding events, which seem to happen more and more frequently as we are experiencing the effects of climate change. And that data that we collect can be verified by a specialist or certifying entity like Jim at NRCS, even if he isn't in the field with us at the time. And it also enables us to make comparisons of the areas that we're collecting data on, both before and after practice implementation. And so this past year, we examined the effectiveness of Practice 315 herbaceous weed treatment using glyphosate on reed canary grass. And when certifying this past summer, there was a significant flood event. And in addition to my coworker being injured in an unrelated activity, it was really helpful to have the drone because I think it would have been almost impossible to complete the workload otherwise. And so I was able to compare my manual walking of the area, wherein I was only actually able to partially get coverage due to difficult terrain and really hot summer conditions. And it took me about 2.5 hours to certify the area. But with the UAV, I had full aerial coverage in a fraction of the time. So the flight was 27 minutes long, and with setup and breakdown of the UAV itself, it probably took about an hour. So that cut my time in half at least. And then I was also able to share the detailed ortho imagery and panoramas with my supervisor. So we'll take a look at an ortho mosaic that was collected at the Pamainville WMA in Pittsford. This was the third year of treatment of Practice 315, so it was expected that there would be some areas of natural regeneration. And we can zoom in on the treatment area for an even higher resolution. And you can even see where the contractor passed with his quad. And it's a pretty awesome level of detail that we can simply share with my supervisor with just a URL link. And then we'll also look at the panorama. We have a way of flight planning the UAV to take a 360-degree snapshot of the area from a single point in the sky. And it includes angling the gimbal up and down so we get a really unique look at the operating environment. And so in this example, it shows ditch flooding at Pamainville, and sometimes in the early spring, we've even kayaked out here. So it really shows how wet this area can get, and in areas that we would probably not walk manually.
This past field season, we went to AALV monthly to collect ortho imagery throughout the growing season. AALV is an urban agriculture project in Burlington that supports refugees and immigrants. Over 250 people of multiple ages, 7 languages, and 5 ethnic groups are being reached here. Each visit, we flew for orthomosaic imagery and for panoramas, which I'll show you in a second. In this spring, we will be flying there for an elevation survey. So back to site scan. So here I have a comparison of our first flight in June and our flight in September. So these were used just to get imagery throughout the growing season. What's really great about UAV technology is that we can, with the automated flights, we can return each month and fly the exact same flight over and over, which is really good for monitoring or again, collecting fun imagery. And here is the panorama that ALV really likes and prefers.
So pretty. So there are a few limitations when it comes to UAV technology. The first and the most significant is weather. We prefer to fly with wind speeds that are below 10 miles an hour, no precipitation. We need to have 3 statute miles of visibility and have to fly at least 400 feet below cloud cover. Our current UAV batteries can fly for a maximum of 30 minutes per battery, and we have 5 batteries, so this does become a limitation for larger projects. We must have airspace clearance to fly. Most of Vermont is clear except for Burlington and Montpelier, where we would need to request airspace clearance from the airport. And then an FAA requirement is to maintain visual line of sight, which I've mentioned a couple times. So Lauren and I have gauged ourselves seeing the UAV at a maximum distance of about 1,600 feet. And this can also be worsened by varying terrain topography and tree lines that may also inhibit our line of sight.
We were recently awarded a Conservation Innovation Grant through NRCS Vermont. The purpose of the SIG is to determine the value of UAV technology in all phases of the conservation planning process. Our goal is to test the technology in a variety of production contexts, including dairy and livestock, vegetables, orchards, and urban agriculture, along with a variety of conservation practices, such as farmstead, agronomic, and riparian and wetland restoration practices. Additionally, we hope to increase the understanding and comfort of NRCS, VACD, and NRCD conservation planners, as well as agricultural producers with UAV technology in the conservation planning process. Also down the line, we want to familiarize the conservation districts and others who are interested in establishing a similar UAV program and help explain the process, costs, and tools needed.
When looking at new UAV models to purchase from the SIG, we focused on models that can withstand high wind speeds, cover large areas per battery, and can have interchangeable sensors. So down the road, we could possibly integrate other sensors such as multispectral or thermal into our program. And so we chose the DJI Matrice 300 RTK with ZenMuse P1 RGB sensor. And that was after much consultation with our UAV contacts across the country. And so the image on the right here is the Matrice 300. It's an enterprise quadcopter style UAV. So it's similar style to the model we have now, except for much larger. It is RTK and PPK enabled, which means that it has integrated sensors and receivers to collect spatial data, which ultimately would result in significantly less ground control points necessary for accurate collection of elevation data. And so some future projects that we have been discussing are for emergency watershed protection for engineering and large-scale wetland elevation surveys that could be larger than 300 acres in area. And in AmeriCorps, we were always taught to use the right tool for the right job. And so I think that the same can be said for sensors. Different sensors have different purposes as they collect data when they fly over the area of interest. And so they actually sample different bands from the electromagnetic spectrum, which would range from blue through the rainbow to red, and then into the non-visible light spectrum of red edge and near infrared, and then eventually thermal. So RGB or red, green, blue collects just the visible light spectrum. And that's what you're seeing in our examples today. DSM, DEM, and ortho photos would be collected with RGB sensors. A thermal sensor collects long wave spectral bands. So people typically use it for precision agriculture, such as soil texture mapping or plant disease detection. It can detect subsurface hydrology and water management, like water stress detection and soil moisture distribution. And so shown on this slide is an example of an area that was flown to look at water deficit and water surplus of a field. And then a multispectral sensor collects visible and near infrared, but it focuses on just a narrow bandwidth, so much narrower than RGB sensor. And this can be used to then characterize vegetation. So you could do vegetation phenotyping, you could look at vegetation health. You can also collect a bunch of complex raster models, such as the Normalized Difference Vegetation Index, or NDVI. And then there's a bunch of other acronyms like NDRE, SAVI, EVI, and a lot of other ones that can help monitor different plants. And multispectral could also be used to look at land use and land classification. And so overall, these additional cell sensors in the future could help to expand our current program and give us other projects.
As Izzy stated before, we have a story map that goes over our UAV program, equipment, and about project management. And I definitely recommend checking it out if you want more information and some more examples, and we can stick that in the chat for everyone. Are there any questions?
Thank you so much, Izzy and Lauren. That was very interesting. So folks, if you have any questions, feel free to type them into the chat or just go ahead and unmute yourself and ask your question.
Must have done a great job of covering everything.
I have a
Where
question.
did the crochet Bernie on a UAV come from?
We have excellent Photoshop skills.
We crocheted the drone, and a coworker's aunt did the crochet Bernie.
I see a question from Jim Eikenberry of NRCS. What advice would you give to someone who wants to start a UAV program?
So I think the first thing would be think about your budget and work around that after you get your budget down, because you could honestly spend like hundreds of thousands of dollars on a drone program, but no one has that kind of money. So figure out your budget first and then figure out what you need it for. And once you know what your purpose is, you can start looking at sensors and seeing what is needed to meet those goals.
Yeah, and like I said earlier with the sensors, it really is like the right tool for the right job. And I think the same can be said for the drone itself. Our initial DJI Phantom was relatively inexpensive, and it's more a consumer level drone, and you could buy it at like a Walmart, for example. So that might be a better option if you're just starting out.
We have another question in the chat from, I think it's Laura from DEC. By wetland certification, do you mean NRCS labeling?
We were certifying practices that were installed. So specifically, we were looking at herbaceous weed treatment. So not specifically like labeling the wetlands themselves, no.
Okay. And we have a question from Karen Bates of DEC. Do you find landowners hesitant at all to give you permission to fly over?
Typically,
most have been open.
Yeah, and typically when we're working on these projects, we're working with a conservation planner who has a good repartee with that landowner already. And so likely they would have discussed in advance maybe why they would want a UAV project on their property anyways. So typically if they're coming to us, they're probably already more amicable for it. So far not too bad.
Great. And Peter asks, what software do you use to plan your flights? Can you explain a little more about the site scan software?
Yeah, I am actually pulling up SiteScan as soon as I saw that question. Let me start doing that. Just didn't want to have any other imagery up that didn't give us a permission to share. All right, so here's one of our test ones. So we do, for the Phantom 4 Pro, we also use SiteScan to plan our flights. We can either do it on the iPad we bring to the field, or we can do it on the computer here. So I would just, it's pretty simple actually. You just choose what type you want to do. So we'll do just a basic area survey. Crosshatch is what we use for those elevation surveys. Do that. We hit next. We want orthomosaic. Things. We can set all of the altitude. We can fly up to 400 feet. So we'll do maybe 350 for this. Set the camera angle and everything. Select the model. Pretty simple. And then if it wants to, it'll let me edit it. But yeah, it's very simple to do flight planning with a model such as the Phantom 4 Pro. And yeah, I would just hit save flight plan to this odd shape.
Great.
And so a little bit more on the site scan software is used for flight planning, and then it's also used for our processing afterwards. So basically we take the SD card from our drone and stick it into our computer, and then it'll show us all of the images we collected, and then we can add them to this flight plan, and it will know exactly where those photos were taken, and then it will essentially orthomosaic them together. And then you can add in ground control points and things to help with the accuracy information.
We have another question from Judson from Agency of Ag. Have you done a basic flying just for real-time visual as opposed to walking an entire field to save time?
We haven't done that. Again, one of our limitations is visual line of sight. And so we have tried to use it. We've tried to use it instead of walking. What we found has worked best for us is actually to kind of walk into our area of interest and then measure how far away we could go and still maintain line of sight, and then do a panorama of that area. So then we can still see even further, but we're really limited by that line of sight because we want to maintain our FAA compliance.
And that's where that new UAV, the Matrice 300, will be very handy because it's bigger and it's black. If you can imagine seeing a little white blob with a bunch of clouds in the sky, it gets very difficult. But from everyone we've spoken to who has flown a Matrice 300 or the older models, they can see it from much farther. And so maybe that's something we look into this summer with the new model.
There's a question from Myra. Just wondering how many engineering companies are using UAVs, or maybe, are you aware of other organizations that might support conservation work using these?
So I don't know any personally, but to bring up a subreddit Izzy and I are part of, UAV mapping, it's full of a lot of UAV professionals such as ourselves. And I would say most of the people in that subreddit are engineering professionals who are using UAVs to supplement their on the ground surveys.
And one of our contacts locally is the UVM Spatial Analysis Lab. We've worked with them a lot and asked them a bunch of questions, and they're in the realm of conservation. So they've been a great resource for us. But not sure specifically engineering companies. I would say that Lauren and I also have looked into what is like the percentage of women flying drones, and being that we're a two-woman operation, it's pretty awesome that we seem to be pretty unique, especially in the state. And it was just International Women's Day, so I thought I'd bring that up.
Yeah.
That's great. Peter had a comment that they use their drone for visual cover crop confirmations. Anything like, are you using the drone for that purpose, or is it more like pre-conservation practice planning?
We haven't used it for cover cropping. We did do some work for NMP, and I think it was buffer mapping. But we found that our current model, like the limitations that we spoke on, is just too small, and the battery life is just too short for the projects that we would want to do. I think it really depends on the size of the area, but I think if you were going to want to do something like that, the worthwhileness is that you don't have to walk it. So you would want something that can sustain its battery and in the air for longer. So maybe something with our new UAV.
Thank you. Any other questions that folks have before we wrap up? Okay, well, thank you both so much. That was wonderful. It was really great to have the opportunity to learn more about this program and the interesting work that you're doing. I am just going to put in the chat a survey, a really quick, probably less than a minute survey. We'd really appreciate everybody completing. It helps us to hear feedback about how this Lunch and Learn webinar series is serving you and what other topics that you have interest in. So with that, thank you. I hope everybody has a wonderful rest of your week.
Thanks for having us.